Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at how to solve second-degree trigonometric equations and also how to find the general solution. Now, when we are solving second-degree trigonometric equations, remember that means that they have a power of 2, so they are quadratics. So in order for us to solve them, we will need to factor or use the quadratic formula. So let's recall the quadratic formula. It is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, and all of that is divided by 2a. So let's take a look at some examples. For these questions here, we're all going to be solving them for the domain where theta is between 0 and 2 pi, but not including 2 pi. So for this first question, we can see that we have sine squared theta minus sine theta. So it is a quadratic. We don't need to use the quadratic formula because there's only 2 terms here, and we can see that we can actually factor out a sine theta. So when I do that, I'm going to write sine theta, open up a bracket, and then I have sine theta minus 1 inside the brackets equal to 0. So now what we know is that either the first factor, sine theta equals 0, or the second factor, sine theta minus 1, equals 0. All right, now because they equal 0 and the second one is actually going to equal 1, I know that I need to use the graph to solve this. So I'm going to draw a little mini sine graph here. And I can see from the graph that sine theta equals 0 at 0 and pi and 2 pi. But remember, we don't need 2 pi because that's not included in the domain. So theta is just 0 and pi. In the second equation, we want to know where sine theta equals 1. And we can see that occurs right here at the very top max of the sine graph. So here, theta is equal to pi over 2, because that's where it occurs. So in this question, we have 3 answers. So the difference between these quadratic equations compared to the ones we've done before, which are just linear, is that we could have anywhere from 0 to actually 4 answers now. So let's take a look at another one. Okay, so for this one here, we can actually factor it, but I wanted to show you how to use the quadratic formula and what it looks like. So what we're going to do, instead of saying x, in our case, the x is actually cos theta because that's actually our variable. So here we have cos theta is equal to negative b, so it's going to be 5, because it's negative negative 5, plus or minus the square root of negative 5 squared minus 4 times 2 times negative 3. And that is all over 2 times 2. So here we have cos theta. And we can solve this. We don't really need a calculator, but we have negative 5 squared, which is 25. And then 4 times 2 times 3, that's going to be 24. So 25 plus 24, we have the square root of 49. And that's all over 4. So here we have cos theta is equal to 5 plus 7, which is 12. Over 4, which actually equals 3. Or we have cos theta is equal to 5 minus 7, which is negative 2 over 4, or equals to negative a half. All right, now recall that our cos theta cannot equal a number that's greater than 1. So for this first equation, there's going to be no solution, since it says that cos theta equals 3. Now for the second one, let me write this a little bit clearer. This is negative a half. We're going to use our special triangles to solve. So this will be 1 and 2 root 3. So this makes this to be pi over 3. So that means our reference angle is pi over 3. And because cos theta equals negative a half, that means that the solutions will be in the second and the third quadrant, because that is where cosine is negative. So that means that we have theta is equal to pi minus pi over 3, which equals 2 pi over 3. And we also have theta equals pi plus pi over 3, which equals 4 pi over 3. So this question has two answers, 2 pi over 3 and 4 pi over 3. All right, let's take a look at some other types of examples. So in this next one here, we have tan squared theta equals to 1/3. It is a quadratic, but we don't need to use the quadratic formula again because we only have one cosine function. Now we're still solving from theta, where theta is between 0 and 2 pi. So here, what we want to do is let's get rid of the squared. So we're going to do that by square rooting both sides. Now remember that when we square root the right side here, we're going to get plus or minus actually, and there'll be 1 over root 3. So we know that because it's plus or minus, tan is positive in the first and third quadrant, but it's also negative in the second and the fourth quadrant. And all of these will have the same reference angle in here. All right, so what we can do is we can actually try using the calculator if you like, so you can see what that's like. So you can type this one in. It doesn't say that we need exact values, so we're going to use our calculator, and you're going to type in the inverse tan of 1 over root 3, and here we get 0.52. So this actually also happens to be the answer or the angle in the first quadrant. Okay, so in the second quadrant, we're going to take pi minus 0.52, and we get 2.62. In the third quadrant, which is this one over here, we're going to take pi and add 0.52. And this gives us 3.67. And then lastly, in the fourth quadrant, we have 2 pi going all the way full circle, but minusing the reference angle, and we get 5.76. All right, lastly, let's do a quadratic with a reciprocal trig function. So instead of actually switching it to its primary, we're going to actually just stick with using the reciprocal. So I can factor here. We know that two numbers that multiply to 6 and add to 5 are 2 and 3. So we're going to rewrite this as cosecant theta plus 2, and then cosecant theta plus 3 equals 0. So that means that I have cosecant theta equals to -2, and I'm going to write this one way over here, cosecant theta equals -3. Now it looks like these won't work, but remember these are the reciprocals. So this will actually be sine theta equals to -1/2. And the second equation will be sine theta equals -1/3. So we're going to do the same thing that we did with the tan. We're going to first find our reference angle. So in this case, this will be 0.52. And we know that sine is negative in the third and fourth quadrant. So to find the third quadrant angle, we're going to go pi plus 0.52, and that will give us 3.67. And I'll write the second one down here. So in the fourth quadrant, theta is equal to 2 pi minus 0.52, which gives us 5.76. All right, let's do the same thing with the other one. So you type this into your calculator, and you should get a reference angle of 0.34. And sine is still negative because it's -1/3, so we're looking for the third angle quadrant and the fourth angle. So the third angle quadrant is equal to 0.34. Oh, sorry. Pi minus 0.34, which will, let me just repeat that again. It actually is pi plus 0.34. So that would be 3.48. And then in the fourth quadrant, it's going to be 2 pi minus 0.34 to give us 5.94. All right, next we're going to take a look at the general solution. So let's scroll down to here. So to find the general solution, we're going to add the period times n, where n is an integer, to each solution. We're adding the period because that's how often each of the graphs will cycle through. So we need to add the period times n, how many times we're doing this. Sometimes it will be possible to combine the expressions to form one expression, but you'll have to take a look at each question to decide if that is the case. So here we have cos theta equals -1/2. So we know that cos theta is negative in the second and the third quadrant. So in the second quadrant, we have 1/2. So this reference angle is pi/3. So reference angle theta r is pi/3. So now we're going to find our two angles. The second angle quadrant is going to be 2 pi/3, since we're going to go pi minus pi/3. And then in the third quadrant, it's going to be pi plus pi/3, so that will give us 4 pi/3. Now we know that coterminal angles, they will always repeat. So to do this, we will take 2 pi/3 and add that period to get the coterminal angle. So we're going to add 2n pi. And we know the period is 2 pi because up here we have cos theta and the value b is 1. So 4 pi/3 is going to have the same thing. We're going to add 2n pi. Now these ones cannot be combined because they're in the second and third quadrant and they're not pi away or 180 degrees from each other, so we can't combine them together. So we'll have to leave it the way it is. All right, let's take a look at a different one. Here we have cos 3x equals -2. Now this is a little bit different because we actually have an angle that has also a number in it, and we can't divide it out. So what we're going to do is, to help us, we're going to write a let statement to say that theta is equal to 3x. And we know how to solve this. So we have cos secant theta equals -2. So sine theta equals -1/2, because we're going to take the reciprocal. And we know from our special triangles that this will be 1/2. So this angle here is pi/6. So theta r is pi/6. So our two angles, one in the third quadrant, is going to be pi plus pi/6, which is 7 pi/6. And then the angle in the fourth quadrant will be 2 pi minus pi/6. So that means that theta is equal to 11 pi divided by 6. Now remember, we're not solving for theta, we're actually solving for x. So we're going to resubstitute this back in. So 3x equals 7 pi/6. 3x equals 11 pi/6. So now we have x equals 7 pi over 18, and x equals 11 pi over 18. Now remember that we are solving for the general solution, so we need to add the period because that's how often these angles will repeat. Now we can see that from here, the b value is 3, so that means that the period is equal to 2 pi divided by 3. So therefore, we're going to say that x equals 7 pi over 18 plus 2 pi over 3n. And then here, x equals 11 pi over 18 plus 2 pi n over 3, where n is an integer. And that's how you express solutions in the general form.